Artificial intelligence and the use of programming languages in building intelligent programs. Artificial intelligence, or AI for short, is a combination of computer science, physiology, and philosophy. Artificial intelligence has many fields. The element that the fields of AI have in common is the creation of machines that can think. One of the most challenging approaches facing experts is building systems that mimic the behavior of the human brain, made up of billions of neurons and arguably the most complex matter in the universe. Artificial intelligence can be defined in many ways. Its definition is as complex as the practice itself. These are some of the ways that AI could be defined: a field of study that seeks to explain and emulate intelligent behavior in terms of computational processes, or the study of mental faculties through the use of computational models. In late 1955, Neville and Simon developed the logic theorist, considered by many to be the first AI program. In 1958, McCarthy announced his new development, the LISP language, which is still in use today. LISP stands for list processing and was soon adopted as the language of choice among most AI developers. During the 1970s, many new methods in the development of AI were tested. During this period, the next great addition to AI languages was done in the form of Prolog, a language that uses first-order predicate logic. This language is still in use today. Artificial intelligence have many practical and real-life applications, from simple logical reasoning to intelligent robots. Among the main practical applications are development of computer games, automated reasoning and expert systems, and systems that understand natural languages. AI is used to designing many real-life and critical systems that require real-time processing, such as spacecraft autonomous control and decision support systems. Now let's consider about the main languages used to develop AI programs. Among these languages are Prolog, Lisp, Smalltalk, and Python. Prolog is a logic programming language that uses first-order predicate logic. It has a purely logical subset called the pure Prolog, as well as a number of extra logical features. The Prolog logic is expressed in terms of relations, and execution is triggered by running queries over these relations. Given a query, the Prolog engine attempts to find a resolution refutation of the negated query. If the negated query can be refuted, it follows that the original query, with the found instantiation applied, is a logical consequence of the program. Prolog's single data type is the term. Terms are either atoms, numbers, variables, or compound terms. Numbers can be floats or integers. Many Prolog implementations also provide unbound integers and rational numbers. Variables are denoted by a string consisting of letters, numbers, and underscore characters, and beginning with an uppercase letter or underscore. A compound term is composed of an atom called a functor and a number of arguments which are again terms. A sequence of characters surrounded by quotes is equivalent to a list of numeric character codes, generally in the local character encoding or Unicode, if the system supports Unicode. Prolog programs describe relations defined by means of clauses. Pure Prolog is restricted to Horn clauses, a Turing-complete subset of first-order predicate logic. Conjunctions and disjunctions can only appear in the body, not in the head of a rule. Clauses with empty bodies are called facts. Iterative algorithms can be implemented by means of recursive predicates. Prolog systems typically implement a well-known optimization technique called tail call optimization. Therefore, deterministic tail recursive predicates are executed with constant stack space, like loops in other languages. The built-in Prolog predicate provides negation as failure, which allows for non-monotonic reasoning. Matching is an operation on terms. Two terms match if they are identical, or the variables in both terms can be instantiated to objects in such a way that after the substitution of variables by these objects, the terms become identical. If matching succeeds, it always results in the most general instantiation possible. This is an example on how the quicksort algorithm is written in predicate logic used in Prolog. Smalltalk is an object-oriented, dynamically typed, reflective programming language. It was designed and created in part for educational use, more so for constructionist learning. In Smalltalk, everything is an object. Other key features are reflection, level of access, just-in-time compilation. Some language constructs, classes, control structures, and methods used in Smalltalk are stated as follows. LISP or Lisp was invented by John McCarthy in 1958. Lisp is an acronym for List Processor. It is a family of languages which are not strictly functional. The key features in Lisp are the use of symbols, first-class functions, flexible parameters, lists, and pairs. Lisp, being a very high-level language, has very few rules and simple syntax, which makes it much more extensible, so the users have total control over what's going on. Interactive, portable, functional, and object-oriented programming language. It is a simple yet powerful language that allows modular programming and has great emphasis on readability. Python is extensible and embeddable into applications. It supports both functional and object-oriented programming that allows rapid prototyping with low maintenance costs. Another advantage of Python is that it is open source and free for anyone to use and edit.